This is the first test, first training, and as you see that we are for the first time using something like 64 virtual CPUs as I will give you a little more information. I will decide wait just for a while. So here is the console. So this is what instance we are using here. Is this time we are using p3 dot uh, 18x large 16x large instance with 428 gigs of memory, 64 virtual CPUs, 8 virtual CPUs, 8 GPUs, NVIDIA Tesla V100, comprising of 128 gigs. As you see here, this one p3.16x large instance for the notebook instance. We are not actually using the training jobs because surely our model is kind of quite complicated. It's not going to be working there. So and yeah, and this 34 for the Linux instances, but we are yeah, sure, we are going on the Linux instances. So $24, and that's it. I'm having fun with it. Let's have a look at some of the frame rates. It's kind of very slow. We have our training data of the 4K images, but we have chosen here for the 1K image for training. That's the 1K image you can see here right away. This is 1K image, and this is being trained with the epoch value of 100 with the earliest topping of 20, and it's using Aptus 2019 data and one more data, diabetic retinopathy data of the 2015. And as usually, because I've just tried to record this video because it would be for the first time I've tried such kind of the instance type. Just requested for the instance for around like the 12 p.m. 12 p.m. tonight and got it back at like the 1:30 a.m. in the not the morning. This is actually not even the night. So and got it up and running. And you see that the GPU memory is almost kind of being used. This 14 gigs, 12 gigs, 13 gigs, 12 gigs, and there are the 7 GPUs all having 16 gigs of memory. NVIDIA Tesla, what the GPU instance name? NVIDIA Tesla V100. And as about the CPU resources, let's have a look at the CPU resources. What exactly the CPU are we using here? Let me just have it running one more time because that it's not giving a little better view here. Okay, still we can see here that the GPU resources, the CPU resources are at the 559, 520, 513. This is the percentage that we are talking about. The Python is all using NVIDIA SSMI is like on the second application uses, and yeah, we have started running it today, and as these are all of the kind of and suddenly I've got also made a mistake that I've just made the commit on the GitHub for my this diabetic retinopathy repository with my secret key of the AWS S3 user. So I just first of all removed that file from the GitHub. Really, it looks like a little scary when you get some of the response from the GitHub. So this is the email that I have received today that Guardian has detected the following AWS keys exposed within your GitHub account. So I gone first of all and install this application, but installing this application on GitHub I think doesn't work any for anything. Still, I was able to see that file and uh, having that AWS secret keys and access keys. This was actually the AWS access key. I would not show you because this you can really enter into my whole of the bucket source. Okay, AWS S3 source with that user because that is having full. Now, as we have gone off the focus, let's focus here. So this is the first epoch we are running. We have not even completed our first epoch, and that's we are the 28%, and as 642 was the samples, and we have just get past the 183 samples. It's almost around going to take her the 23-minute rest. 23 from now 23 minutes, and is running from the 13 minutes, and we are paying for like the $24 an hour. Really a big instance that we are running here. $24 an hour, yeah. And as the frame per second that you are considering, the 25 frame per second, 25 frame per second, yeah, this is even a good data. But actually we are using here the 1K photo. Previously I've been ran it on Tesla P100 instance of the 16 gigs with just small instances, 12, 4 core, either the 8 core was the CPU instance, and that was even quite impressive with just the half K photos, 512K, 512 image size. That was around give me the same frame per second, and I don't sure that the why it is giving me the same frame per second with having such a high level of instance, with such a high level of compute capacity. 64 virtual CPU, 488 gigs of RAM is just available here. We can have a better look here if we'll just put this all in one. Let's have a look in that way. If we go in the terminal, this is okay, but for the CPU states we gotta have to come here and just use our again. So here we go. This is a CPU that this you can see here, the 546, 445, 420, 295. These are the CPU resources being used from this files, and the memory uses, this is we are having 503 gigs of memory, but actually the memory is here for 88 gigs of memory, so it's almost this just a little increase, not a little increase, but if you are assembling that so many of the memory cards, that gets a little increase a little. And we are using 144 gigs, 144 gigs of memory from the 500 gig, because we cannot opt for the uh, all of the things in your own way, because you cannot customize them on your way. Like if you need like the 200 gigs of memory with actually how much memory, how much GPU memory you are using here? We are using here 128 gigs of GPU memories with the such kind of the 64 virtual CPU, that's the 64 core CPU. Yeah, really, we cannot even such buy such kind of things anyway. So this is kind of the actually the facilities that you can get in the cloud. And AWS SageMaker notebook instance is quite great. And we have also tried these process training jobs and hyperparameter tuning jobs. But having a look at the live updating on, actually it looks very great when you actually see the training a model, but it is so slow. I gotta have to kind of for reaching up to the 100 epoch. I don't sure that how much gonna have to go for. Just see that we are already having 81% accuracy, 76%. It's dropping up because it is the first epoch. I will let it run for like the 6 and 7 hours. So multiplied by 24, that would be a big money. Yeah, and I will update it again, or like we will give you a little more information on a little progress with this training instance of this training with this instance. As you can see, this is the training size where Aptos 2015 falls to workers 64 workers. You can see it. Training box 100, and we are almost using the very small learning rate. Where is the learning rate? That was around like the 0.001 that we have set it here, and it's using here a pre-trained model. That's one more thing. It's using here a pre-trained model, and there's nothing. I just showed you a little different thing, but you just do not have to focus on that. Retinopathy, and we are almost having our data set. As you see the data set, let me show you the data set. So this is the data set here, data set retinopathy here, and here we have got this Aptos 2015 data. This data is almost let me have a little about actually the size of this data, calculate total size. So these test underscore images 760, 10 underscore images 760, this almost comprises of around 80 gigs, 81 gigs. This is already 24 gigs. We have 28,000 objects, and the same goes for the Aptos 2019 data. So this is 9.5 to that almost 10 gigs of data. And this was there was one more file. This is actually this one. Where is the file? That file has still not removed from here. I'm gonna have to re-express it just. Oh, excuse me for that. So this was the actually the IPMB file where we have just put our GitHub resource, actually AWS secret user keys, resulting in the flagging by the GitHub that your API keys have exposed. You better have to take your action to remove them. And I think I have just recently received one more email. That email is here. Let's have a look. So Git Guardian, one incident detected. One application have been added to your account. Okay, good. We have added it. Your decision. And this is thank you for Git Guardian. What exactly the features? The private repos, free Git collaborative within a 30-day free trial. And one instant detected a secret key detected. AWS secret keys. Secret detected. Get on the sit on the see on the Guardian, see on the GitHub. Actually, do they have fucking created the record of my guess secret access? So look what exactly we are going to have. One addition and 545 deletion. Actually, I have deleted it, but they have kept it at the back of what should I do now? This is just for me or AWS secret keys? I have to. Can I delete it? How can I do? How can I remove it? Don't even try. Don't try something like copying these keys and doing something bad with my AWS. There's three instances. What should I do here? Actually, what kind of option we have? There is edit file, remove it, delete file. There is no option to delete the file, split it, but that would give us something. And now this is actually showing me the changes. I have to remove this file. What the fuck is happening? Log this conversation. Actually, I have already removed this file. That file is not containing anything. But for removing the file, it takes a little. This is exposed. Okay, you have exposed publicly. The test credential. This is low risk secret. Not a secret. This is a test credential. No, this is not a test credential. This is actually a real access keys of my instance. I really have to remove this user key now from my sources. Okay, let's just disable it for a while. Might be will be willing to come with this thing again. Okay, here we go. They just kept it as that. They just kept it as a backup. See here, this file this file we have been talking about, but this file is no anymore contain anything. I've removed everything from this file. I cannot delete this file. GitHub has not that such kind of features, and I'm gonna have to back up here, buddy, because I am here for the training, not for discussing you with some nonsense things about exposing my secret key. Here we go. This is the IAM profile we are, and go on the users. And what was the users? Who should users was 29 days, 35 days. I not even remember that which user was that. Now, okay, we'll take the actions around. Actually, do we have a record to find? I think it will be Where we copied it from? We have copied it from the character mesh from web S3 access. Character mesh from web S3 access. I don't think so. Text section, text download, test. I think I have assigned the character mesh from web S3 access. This one was something, and I cannot just remove these users. These users are being held up from some various sources. If I will remove this, I think I can even lose some of the uh, plugins in my WordPress of my website. But I can, so I can't just remove them. Okay, let's back it up here. We'll find a way. Actually, I've removed it, but do not try to use it, buddy. Or either I will restrict the access to only certain public buckets that you will find the data anywhere. Those public buckets will contain some important things, but not actually that important that will going to make me very, very lost. Why are we back at this thing is again here? It's hanging up a little. And as you see, I will show you something here. This that I have requested for the P2 or P3 instances with 64 new limit value, and they at the 217. That's the GMT 5:30 time. Yeah, I have requested 217. I thought it was 12. Whatever. So here we have requested it on the 217. I have also told them that my some of the P2 or P3 instances that are previously using like the xlarge and 2xlarge of the P2 or P3 instances. There was like the 16 gigs of memory and for virtual CPUs, 8 virtual CPUs with very less computing resources. That was not even possible. I have the data that I'm using. It's around like the already have become of around 190 gigs 91 gigs of data, and this data was when we have not extracted all of the files, and when we have extracted those all files, all the files or the 4K images surely it's have run up to the like we can have a look where we can find I think this was actually we have, can we have a look here? My tool available here. Yeah, this is disk management. Let's have a look at the disk management. I'll just go here and execute this. This is not online. When we'll execute, it will become online. So this is how actually our of the 196 gigs we are using 100 gigs. 87 gigs is free, and 54% we have used. This is SageMaker instance. So we have almost used 54% of that's 100 gigs. Everything is here, just the data. Nothing is codes like the 100 maximum 100 MB. Most of them are already containing some of the actually the labels, CSV resources. So it's all here is, and you see that uh, as we are having here how many cores? We are having here 64 cores. So how actually it's giving us that the 600% of the CPU resources being used. How actually this isn't working? Why the last one is just the last one is not? CPU resources are here 16.4%, 20.9%. What exactly this number? USSY used resources, system resources, NY resources, ID, SD, memory, 500 or 163. 3 of memory we are using free, 340 gigs of memory free, and these are the buffer memories. And yeah, and about the GPU, I've made it to update on every 2 seconds so that I can have a little look exactly how many resources being used and how many resources is it working even or not working. But it's consistent. 14 gigs, 12 gigs, 13 gigs. Why it is decreasing? No, actually, it's not decreasing. It's just you can even have here a look on the Tesla V100 55C temperature. There's temperature. and how many power, how much power they're using. 90, 75, 93 watt, 110 watt, and the percentage cap, usage cap, meg GPU util. There are tons of information have been given, and they are rising on the CUDA version 11.0. I have also tried here the G4DN.X large instances. They come with G4DN.X large instances for especially the cloud gaming. They also come with these CUDA versions, but when I try to use with for the some training instances, it doesn't work. It don't work. Actually, then I tried to install some CUDA toolkit and CUDA uh, NVIDIA drivers. They still didn't work, but exactly I didn't figure it out. And finally, the actually the driver, actually the I don't know what exactly happened. The actually the GPU driver was I think unlinked with the system. I even tried updating the Windows, and these things takes that instance was even costing me around like $0.7 an hour, especially for the Windows instance, $0.7 an hour. So that's it. Was a big of a hassle. Actually, because we have worked on those instances because of one reason, and I was needed to prepare some data set from like the 80 gigs of data set. These data sets aren't just get prepared on your own local instance. Downloading those files is really, really impossible with the level of the networking connectivity that we do have. Okay, so what we done that we have downloaded it on the cloud. That's the G4D.xlarge instance. Then we extracted those files. There was some of the another kind of the tweaking we're gonna have to do. We're gonna have to just volume up all of the zip files. That kind of the thing was not able to turn this SageMaker instance, SageMaker notebook instance. It was just hanging up for like the hour and hour, and we have been losing all of the credits in that. So what I tried that, let's just go with a G4D or X large Windows instance. If you GUI instance, then I tried there and merged those all of the volumes of the zip files, then extracted them, uploaded them to S3, and we also ran into one more problem that we have not zipped those files and directly uploaded all the files to S3 one by one image, around like how many images, how many we have now calculated. So this is actually the 89.1 gigs of data, so this is around 100 gigs of data already here, 100 gigs of data set, and 88,702 images are here, so 702 buckets. And mostly here at the test images, you see that the 53 gigs is test images and 10 images 35 gigs. But we are training on both of the images. We are validate on some more. We are training both of the images, not the validation. The validation is already in this thing. Testing, that testing will happen on some real world data set. And I have also made this bucket, that's data set as retinopathy bucket public. So anyone who is willing to get some data from this bucket, and I have also uploaded it on the Kaggle. This dataset on the Kaggle, that's 89 gigs of datasets. Really took me forever to upload. Not forever to upload because I have uploaded from the G4D.xlarge instance. It was so quick, even more quicker actually than that. So this was where the dataset we have prepared. So this is the dataset that we have prepared, 83 gigs of our dataset after zipping, unzipping, and so these are the files. These are the actually the sample submissions. These are test images, 10 images, 89 gigs of data. It's saying that here, and I've made it public too. Then anyone, so just search the data diabetic retinopathy blindness detection C underscore data. Here C underscore data stands for competition data. Okay, because anyone can come here. There's already tons of data are available, but the data available here, actually the Kaggle has provided the data, these data in some split form. They have just splitted some GPUs zip files and then just posted it here. But even if you download one zip file, it will not work. Okay, why? Because these are the volumes. These volumes must have to be merged together again after downloading. After downloading for the test volumes, test must have to be merged together, and training must have to merge together. And what you will find here, so just go in the test underscore images, you will find here that See what kind of internet connectivity I'm having. Jupyter Lab, how long are we gonna run? We have just initiated what even not we have completed the first epoch. It's like the 93% we have completed. We'll see actually the what kind of the I was yeah CUDA toolkit. The I just forgot one thing that this instance is having GPU memory, GPU model. I'll ask one thing that CUDA compute capability. So this is 7.0 CUDA compute capability is having p3.xlarge with NVIDIA Tesla V100. I have used one more instance G4DN.xlarge where those instances have Tesla T series, Tesla K series, Tesla K series. Okay, let's just have a look. What's the problem in just fucking typing a little? So G4DN.xlarge, I have been using G4DN.xlarge because they really do not allow. You literally have to call them after and after, and especially this will not be available in all of the region of the AWS. Only in the specific region they allow these things. 16 gigs of memory, 4 virtual CPU, 16 gigs NVIDIA T4 Tensor Core was that. But actually, if you will see in the uh, instance or in the GUI of the Windows after logging in into the Windows, and this is having the CUDA compute capability of 7.5. So as the higher the compute capability, CUDA compute capability, it works better. It is just like the versioning software. Okay, you can have a little more information CUDA compute capability. On Wikipedia pages, I have also found some information about the CUDA compatibility and compared based on that the which one will be the better. I tried everything. I have almost gone with all of the accelerated computing resources from the AWS, and I think I am already on the peer level. So that is the one that we are using is p3.16xlarge, and there's already the v2.16xlarge there. So let's have a look at the p resources. So I tried to go with the p3.16xlarge. That's 488 gigs of memory, 64 virtual CPUs, and 8 GPUs with 128 gigs of GPUs memory comprised of from the 8 CPUs, and this is having CUDA compute capability of 7.0. I can even have targeted this one p2.16xlarge. This is almost having the same resources, but its charges are little so much lower. Why exactly? So this is having CUDA compute 3.7 and 192 gigs of GPU memory with 64 virtual CPUs and 16 GPUs with 732 gigs of memory. I think I could have to try this one. This is having 192 gigs of memory, GPU memory. That's what I need first. CPUs are not getting used, but the CUDA compute capability is at 3.7. That kind of will worry me. And p2.16xlarge instances. So these two instances we have been targeted, but because of we are literally not using memory, we are using around how much memory you are using? 133 gigs, 1.5 gigs, 150 gigs from the 500 gigs of memory. That's why I decided to go with, but actually we are not having any profit here around. We are already literally paying a $24 an hour, and we'll be paying here $14 an hour for the 192 gigs of GPU memory for the CUDA computer. This is CUDA computer that doesn't matter that so low highly. But actually, first of all, we need the GPU's memory. What do we miss? Why do I miss this thing? I have missed here the thing that I can even have targeted this one. Okay, let's just have a look that how longer will it train with this instance. 128 gigs of memory, 992, because we are using literally very high sizes of the images. Processing those images also takes time. And how much we are so oh, what the fuck? This is the folding is still running still. I think we have got 4 folds. So there are the 4 folds. Where is that folding? Folds. What's that? So there this dash f0, dash f1, dash f2, dash f3. Why it is not showing the parameters here? This must have to show here. I think where is that left? Four folding, so it will go on four folds to complete one epoch. So even if I left this one, so CLS accuracy we have 0.67, 0.76, CLS loss 0.53, LP regularization. So it's literally took 34 minutes to run one fold. So I think I'm gonna have to quit it. Literally I will flush my money. Okay, what are you gonna do now? Okay, we will update with some of the more of this information about what I'm going to decide here. So this, as you can see, CLS accuracy will literally will go over. I think I gotta have to go with that P2 instance, p3.16xlarge instance. It will just depend on that how much resources you are using. You are using almost complete of these GPU resources, but it's decreases as we go on up. 14 gigs, 12 gigs, 13 gigs, 12 gigs, 14 gigs, and here the terminal 2, we are almost using the complete CPU resources. And as we are talking about the actually the SSD, that doesn't matter here. So what should I have to do here? Let's just update. Let's just go with the this instance because it will have the higher compute capability. 192 gigs. I think that's the highest possible. 256 GB is here, but you will not get this much. 96 virtual CPUs. Actually, these are on demand. That's why this is not on the spot pricing. You will not even get these on the spot pricing. For even the spot pricing, you have to request them, and requesting even takes a. I can show you a little more about requesting. Right, this is here. No, it's not here. Stream management console. This is also the stream management console. Why it is here? So this was the trace tunnel images. So let me show you actually the my quota of the US is to 1. AWS is actually the so big, buddy. Literally in every region you can have these resources. So EC2 compute capability for the on-demand resources. Actually, it's not. I think still have updated here on FS spot instances. That doesn't even FG in spot instances 8 they have allowed me. For the C compute instances, you can literally have as much CPU you want on demand. So as you can see, this still has not updated here. Why, I don't know exactly. For this P instances here it has to be 64. That's currently I'm using with this instance. There's something happening, but I have to be a little careful. So what is happening is, first of all, pre-processing the image files. That's images. See the GPU CPU resource will be spiked up. As you can see, it says spiked up. Every CPU resources is having the Python file, and how many they all just processing the image files with the OpenCV. That's what we are using here. And actually, one more problem here we have faced here that we are using different files. From some of the sources, we are using the JPEG files, and some of the sources. Actually, the data set available from the uh, after 2019 is available in the form of the PNG format, and converting these is really hard. It's not possible to convert them. Again, it's not possible to convert those images to JPEG, but we gotta have to we was here certain of to conversion from the JPEG files that is available from the after 2015, as you call them normally, because that has been hosted in the 2015 on the Kaggle, and they have provided almost 90 gigs of data set. And the 2019, I'm sure that this is from the India. India is kind of a very low in considering collection of these data and storing these data for such kind of big competitions. They have paid like the 50K. So this was the competition. This was the competition. Actually, this was not the competition. This is flow class light talk, light adaptive retinopathy. 83 gigs of data. So here we go. Here we come. Now 216 gigs. I think we have pre-processed the files. Now we will go in and see the CPU resource. GPU resources is still again spiking up, and we are again back on the. So see, you can see now 0.83 we are running up with the accuracy. How long are we gonna have to run it? And I suppose that even if we are running for the 100 epoch, we literally have around the accuracy of regulation loss 0.37, 0.717 is regulation accuracy as of this time. But the previous regulation accuracy is 0.683, 0.504, and spiked to the 0.833, regulation loss 0.159. So the model is working perfect. I really could not show you that the model files. Model files, if I'll show you locally, that will be better option. So let's go ahead and do this. So here we are with the retinopathy 2, and this is the model file. Is it actually recording or not? Let me first of all confirm it. Yeah, still it's recording, and is it doing some changes? Yeah, sure, it's perfectly working here. So this is actually the directory structure. Here was let me just make some changes and commit it to my GitHub. And there are some of the resources my CPU cannot handle such kind of big project. So what have I done? I just made the changes, edit them, and make them to work on my cloud instances. That's where we are, and we have been actually working here on the prediction part. We have done some changes. We have done some changes, and those changes are literally visible here. We are training with this instance. You can see this. This is not at all will be any kind of interesting thing for you rather than just watching my model learn to classify the diabetic retinopathy severity cases. Let me just walk you through the competition. And tomorrow I have also one more presentation at my college for one competition. That competition was even great, and I gotta have to even prepare for that. This is what's the time it is? This is 4:07, and GMT plus 5:30 time zone. So it's almost not the night time now. It's almost on the morning time, and I'm not even still dreaming. Okay, so what are you gonna do? We'll just left it to run for around 12 an hour. How much it's going to cost me for running it for the 12 an hour? Let's just have a just have some calculations around. Okay, so let me just suppose that we are running for the 12 hour, and the rate that we are currently using is 24 point. How much is that? No, I am having a little cold here. So 24.48. Actually, these are not the perfect pricing. We can have the perfect pricing on somewhere. I just literally talk to them that I'm requesting about the resources and get the CPU course. Amazon seismic analysis, and let me just have a search for it. ec2 instances pricing. And here we go. Only one instance pricing. No, not this source will be perfect. Seismic pricing. So here we go. I'm currently in the North Virginia region. we have to find here what kind of the source. We have to find here P2 P3.xlarge. So there the P3.16xlarge. See, it's having $28 an hour. There it is saying that the $24 an hour, but it's not. It just gets directly updated from the AWS sources. This is a different, so this is a GitHub project. So $24.4, and it's saying that the U will be cost $28 an hour. I gotta have to think of something. It's really going to. And what about the P2 resources charges? P2 resources, P2.xlarge. Let's just have a look. So P2 is not available here. It could be. I'm saying that I need here. As the P2 is available, even if you go for here and so this is the P3.16xlarge we are using. 200 gigs of elastic volume, EBS volumes. Just have a look at what kind of instances here are available that I can upgrade to. So here we have P3.2xlarge, P2.xlarge, P2.16xlarge is available here, but actually they are not giving the pricing on the P2.16xlarge. Why? We have to select something on Studio on Demand. This is going to training. So here see this P2.16xlarge developed. See, this is very cheaper rather than actually going with the $28 and 32 gigs 64 virtual CPU. The larger GPUs, 192 gigs of GPUs, even P2.16xlarge is contained. Why exactly I have not targeted this one? Because of just this 732 gigs of memory. You is not willing to go on some higher memory, because memory was a real cause of having the higher money. But I really didn't see even the actually the charges of these instances. I've just been frustrated with running with some small instances and having seen no any progress so far. So now we are at 23%. So what are you gonna do? Do I just have to stop it for a while and just pay them for an hour and again start with the P2.16xlarge instances and pay them for the next 12 hours? I think we're gonna have to do this. It's really necessary, buddy. Let's save these ones so that next time we just do not have to okay, save. We have saved it, and actually where it has been saved, it's not here. Surely it's in the retinopathy too. So this is untitled. We're gonna have to open this file, not this file. Diabetic retinopathy. We will upload these files manually. I'm not going to take this risk again of exposing. So download it. It will be available here. And this one, what have I done here? I have just opened this one was the previous instance. This is also available here. And actually, where am I running? Both of them are the same instance, or this instance is the real instance? This here, no, I. Both of them are same instance, and we have just opened them. So this is the diabetic retinopathy. I have one more diabetic retinopathy here, and this have been edited an hour ago. Let me just have a look that this is also working. Or so this one is not. This one was the previous cases. We have been running with some errors, so you can remove it. And this Jupyter Colab is perfect here, buddy. With little, I will not be going to just doing some of the changes, because those changes do require some other refresh in the browser that will lead me to just fuck up with the actually the process of training. So let's just have a look to complete this 29%. Actually, we are off the task here a little. This is 594, 596, everything is perfect. Now what about this resources? It's almost also perfect, being used perfectly here. Okay, let's just stop it for a while.